Okay, so after method of joins, ang next topic is all about zero force members. So, meron tayong mga members na makikita sa isang trust kung saan hindi naman siya nagke-carry ng load. No? It does not support any loading. So, kaya siya tinawag na zero force member. So, nandun lang siya in the truss para mag-increase ng stability, to increase the stability of the truss during construction, and also to provide added support kung sakali man na mag-change ang loading natin. So again, zero force member does not support any load. So the force in that member is 0. So F member is equals to 0. So meron tayong criteria in finding these zero force members. Accordingly, ito yung first. If only two members form a truss joint. So if meron tayong joint na ang nandun lang is dalawang members, and walang external load or support reaction applied to that joint, then the two members must be zero force members. For example, again, if only two members form a truss joint and no external load or support reaction is applied to that joint, the two members must be zero force members. So example, this one. So, hanap tayo ng joint kung saan it's only made up of two members. So, mag-start tayo sa left. So, it's from joint A. So, ang joint A is a two force member, right? And walang naka-apply na load, external load sa joint natin, o di kaya wala ring support reaction na nandito sa joint na to, right? So if that's the case, then therefore, this member, yung force sa AB, equals to 0 yan. And the force AF yan, no? Force AF equals to 0. And also, the force in AB is 0. Kasi nag-meet siya doon sa criteria natin. Okay, so meron pa ba? So, tingnan natin sa joint F. So, hindi yan pwede kasi may pin dyan. Mismo sa joint. Sa joint E naman, maraming members ang nandyan. Sa joint C, may roller. So, may reaction dyan. So, hindi pwede. Sa joint C, may external load na P. So, hindi pwede. So, dito tayo sa joint T. Walang external load applied at this joint. At the same time, wala ring reaction. And also, it's made up of two members lang. Now, since that's the case, these two members is actually, yung force na nararamdaman nila is 0. Wala silang sinusupport na load. So, FDE equals to 0 and FDC equals to 0. So, it's pwede actually natin silang tanggalin in this truss. Pag matanggal natin itong apat na members, it still support the load. So, ito lang pala yung kailangan for that truss to be stable. So, 5 members lang. Yung additional dyan na apat, yung mga zero force members, hindi sila nagkikarry ng load. So, pwede natin silang tanggalin. Now, may isa pang criteria na pwede nating tingnan in order to determine zero force members. Now, this time, kapag tatlong members na. So, if 3 members form a truss joint for which 2 of the members are collinear, so they are collinear yung dalawa, sa tatlong members na yun, then the third member is a zero force member, provided no external force or support reaction is applied to the joint. Again, kung ang truss joint mo is made up of 3 members, so let's say isa, dalawa, tatlo. And yung dalawa dun, ito at saka ito, they are collinear, so same line. So if that's the case, yung pangatlong member natin is a zero force member, provided that in this joint, walang reaction, support reaction, and walang external load. Okay, so example, tingnan natin to. Hanap tayo ng joint kung saan it's made up of 3 members. So we have joint D. Now, notice, isa, dalawa, tatlo to. Dalawa sa members natin, collinear. So therefore, this is equals to 0. Now, sa joint C, pwede pa ba? Ilan yung members sa point C? Isa, dalawa, tatlo. Dalawa, collinear, walang external or support reaction on the joint, same as joint D. Therefore, the third member is 0. Okay, sa joint B, hindi na yan 3 force member. Ito naman, hindi rin siya 3 force member, 2 force yan. And joint E, so yan lang. So, i-remove natin yung 0 force members from this truss. The truss will look like this one. So, it is enough, itong tatlong members na to support the load. Now, I have here an example. This is a Fink roof truss. Another example. So, assume all joints are pin connected. Hanapin daw natin lahat ng 0 force members. Hanapin lahat ang 0 force members. So, I will be starting with the joints sa E. Sa joint E, hindi pwede may support reactions. Sa joint D, pwede. So, dito siya under sa 3 force member kung saan dalawa ay collinear. Walang external or support reaction sa joint. Therefore, the third member is a 0 force member. Next, sa joint F. Sa joint F, walang external or support reaction. And it's made up of isa, dalawa, tatlo kasi nawala na itong FDF. So, tatlong members and 2 of which are collinear. Therefore, the third member is 0. Sa joint C, hindi yan pwede because may external load dyan. Then, dito tayo sa joint G. Sa joint G, walang external load or support reaction. It's made up of 3 members, 2 of which are collinear. No? So, therefore, the third member is 0. Sa joint H, tingnan natin sa joint H, ilan yung members dyan? Isa, dalawa, tatlo, apat. Hindi yan belong sa criteria. Sa joint B, hindi rin kasi may load dyan, external. Sa joint A, hindi rin because may support reaction dyan. So, therefore, the 0 force members here are force in member DF, force in member CF, and force in member CG. Okay. So, ano yung silbi sa pag-determine ng mga 0 force members? So, if you know how to inspect the truss, kung ano man yung mga members na may kung alin man sa mga members na nandun sa truss, kung alin man dun yung mga 0 force member, so sa analysis mo, you can actually remove them immediately. Pag ma-remove mo yung mga 0 force members na yon, maliliit na yung mga members na i-analyze mo. Okay, so mas masisimplify pa yung analysis if you know how to determine or spot kung ano ba yung mga trusses na members in the truss na 0 force members. So, yun yung sa 0 force members. So proceed tayo sa next topic, which is yung pangalawang method in determining or analyzing the forces in the members of the trust. So method of sections. So kanina natapos natin yung method of joints, ngayon method of sections naman. Now ang kagandahan ng method of sections na to is if we are looking for the force or forces on a specific member only. So if ang concern natin hindi yung lahat ng forces in the member, specific lang like isa, dalawa, tatlo, using method of sections, we can directly determine that force in that member. So, ano yung basis din ng method of sections? If doon sa method of joints, ang basis is kung ang truss is in equilibrium, then therefore the joints also is in equilibrium. Dito naman sa method of sections, if the truss is in equilibrium, then therefore the segments, any segment of the truss is also in equilibrium. Okay. For example, consider the two truss members shown on the left. So, in this slide, on the right siya. So, itong two figures natin. If gusto daw nating i-determine yung forces within the members, then what we can do is cut each member into two parts, and thereby expose each internal force as external to the free body diagrams shown. So, ito yung, sa pag-cut niya, dito siya nag-cut sa section with the blue line. So, pag-cut niya dito, at saka dito, na-expose yung internal force sa member natin. And now, it's external to the free body diagram. So clearly, it can be seen that equilibrium requires that the member in tension be subjected to a pull, whereas the member in compression C is subjected to a push. Okay, so diba originally we have here the member in tension. Pag-cut natin dito, so lalabas yung internal. So if this is T here, kailangan the force here sa pag-cut natin, yung lalabas, is in tensile or tension rin. So, it tends dapat to pull this member also. So, if dito naman sa baba yung titingnan natin, kasi dalawang parts to, sa pag-cut natin, naging dalawa, upper and lower. So, dito sa lower, so, ang partner ng tension natin is ito. For it to be a pull on the member. So, dito naman, compression. Originally, yung nafe-feel ng member. So, we cut it through this blue line dito sa section na yan para lumabas yung internal forces. So, considering the upper segment, so this is our internal force, no? So, coupled with this compressive force sa taas. So, yan. Then, ito rin, opposite sila ng direction dito. So, upward here will be downward in the lower segment. So, by Newton's third law. Now, aside from one member, we can also use method of sections to cut or section the members of an entire truss. We can cut or section the members of an entire truss.